We have two speakers joining us today, both from EPA. We have Lisa Bacanskas, who is an environmental scientist, and Sargon de Jesus, who is a physical scientist with EPA. So Lisa, I will now hand it over to you. Thank you so much.
Great. Trying to see the slides. Hang on. Are you showing them, Liz?
I hope
You
so.
are. Oh, okay.
Yep, I can see them. Yep.
Okay, great.
For some reason they're not coming up for me, but that's okay. Let me check my view. Huh. All right, that's all right. We can get started. So thank you so much for having me and Sargon here today to talk about EPA's Climate Change Indicators Project. We hope you find this information really informative and also encourage you to share your thoughts on any ways we can improve the resource and data sets to consider. So just wanted to start out with that to plant the seed as you listen to the information that we're presenting. I sit in EPA's Office of Air and Radiation in the Climate Science and Impacts branch. We're based in Washington, D.C., but I live in Western Mass in the lands of the Nonotuck. The indicators are one of our flagship projects, along with Climate Impacts and Risk Analysis, or CIRA, which is a project that uses modeling to quantify future climate damages and benefits based on different greenhouse gas emission scenarios. We also have a related tool that looks at different temperature change scenarios and damages related to that. Colleagues in our group also support the Arctic Council and work on the Black Carbon Expert Group. And our branch also runs the EPA climate change website. And we're starting to look at developing more content that features the Arctic and Alaska. So on the roadmap today, I'll kick things off with some background on the Indicators Project, talk about our website and the report we just released this summer. And then Sargon and I will walk through some of the indicators that we highlighted in the Alaska chapter. So first, a little, next slide, slide 2. So first, a little background. We started the Climate Change Indicators Project in the mid-2000s. So why did EPA start this project? Well, one of the early goals was to show the public that climate change wasn't something happening far away and sometime far in the future, but we were seeing impacts in the US at that time. We've continued to hold on to this purpose and have kept the resource up to date and a comprehensive kind of resource of these climate impacts. We are curators, so a majority of the data collection and processing is led by groups outside of EPA. Without those partners, the project wouldn't be possible. We work with over 50 data contributors. So these are technical experts that come from a number of federal agencies, including NOAA, CDC, USGS, to name a few, and also universities, NGOs, international organizations. The indicator set present historical data, long-term observations. So the project does not include projections. The focus is on the US, mostly national, that's where our strength lies. But depending on the indicator, we do present some subnational, regional, state, and community information, and also include some global changes for context. The website resource is dynamic. We update the indicators as data become available and as resources allow. So a group of foundational indicators we update every year, and then the rest as we can. And we are, working with data contributors as data sets change, exploring new metrics, filling key gaps in the resource. We're committed to transparency and peer review. We provide the methods and data for each of our indicators via the website. And in terms of products, while the website is the core resource, we periodically release reports. So the first one came out in 2010, and then we publish reports about every 2 years. Though in recent years, the website has really become the core resource that we maintain. We also participate in the Global Change Research Program's indicator work group and contribute to the National Climate Assessment. Slide 3. So I wanted to briefly introduce you to the website. So whether you're a layperson or a data tinkerer or anywhere in between, you can find information that kind of suits you, meets you where you are. The indicator figures, the data used to create those figures, and the technical documentation are all available on each indicator page. So there's a snapshot of one of the pages on the right that shows US and global temperature. Each indicator metric has a clickable icon that can take you to the data and image download and the web map if there is one. Our visitors to the website have grown over the years. We had almost 900,000 unique visitors in 2023. So we are continuing to think of ways to make the information more accessible, to visualize data in new ways, make the site more engaging. So we're actually phasing in making a lot of the graphs interactive. Next slide, 4. So for those inclined towards spatial data, most of our indicator maps are available publicly through EPA's Geo platform so that a user can incorporate them into their own story maps, into their analyses. You can get to the layers linked from the indicator page on the website. We also house all the layers in a map viewer portal, so they're available in one place. So I encourage you to go and check that out. All right, so slide 5. This and the next slide show the list of indicators in EPA's suite. So we started with 24 indicators in 2010 and now we're up to 57. And that includes over 100 graphs and maps. Some of these indicators present a single measure or variable. Others have multiple measures that reflect different data sources or different ways to group, characterize, or zoom in on the data. So the colors represent the groups of the indicators as we present them on the website. So yellow is greenhouse gases, the drivers of climate change. Orange is weather and climate. So that includes some of the fundamental changes we're seeing in temperature and precipitation. Snow and ice in the blue includes measures related to like snowfall and cover, sea ice, glaciers, permafrost. Next slide, 6. And purple, it's oceans and coasts. So those are indicators that relate to ocean temperature, acidity, sea level rise, coastal flooding. And then green for ecosystems, and pink, health and society, which features some health outcome data, some energy related topics, some of our more agriculturally focused indicators. And so while the set definitely doesn't represent the entire range of changes that are happening now in all these different places, it covers a lot of these measures and causes effects of climate change for which we have these kind of long-term data sets. Next slide, 7. So one of the ways we reach our audiences is through periodic release of reports. So we just released the 5th edition indicators report in early July. The goal of the report is really to help people connect what they're seeing in their daily lives to these broader and longer term climate changes. In this 5th edition, we've organized the information in 8 chapters. That's in the blue box on the left. Indicators related to health and societal impacts cut across all of these themes. So we integrated those throughout the report. The little graphic on the bottom just shows the chapters as they're organized online. And just for each of these chapters, we mixed in indicators from the different topics. So for example, the chapter Heat on the Rise includes indicators from both weather and climate and health and society. This kind of more narrative approach helped us to highlight some of the interrelated indicators and kind of tell more of a story than we can do on the website. The report doesn't include all the metrics we have online. It just includes a subset. And along with the report release, we updated a lot of these indicators with new data. Next slide. So to give some examples of this type of supporting information we included in the report, so these aren't included in the on the website. So the core focus really is on the highlighted indicators and the data sets. But in this edition, we really wanted to not just present the numbers, we wanted to make more connections to people, the real world. And we also know people don't experience climate change equally. And so this was one way that we could provide some of those examples of disproportionate impacts through call-out boxes. So we did that in kind of three basic ways. For each indicator, we have information on why it matters. This also mirrors some of the information we have on the website. For example, for snowpack, we highlight the importance of the water cycle for agriculture, for drinking water, etc. The second thing we wanted to do was highlight what EPA is doing, what communities and individuals are doing to adapt to and address climate change. So for example, in one of the taking action boxes, we highlight an EPA air nav tool and smoke map so that you know, if folks are experiencing a smoke event, they can look online and see where the affected areas are to help them prepare. The other call-out boxes tell stories of impacts on certain communities, such as drought on tribal communities in the Southwest or permafrost thaw in Western Alaska. Next slide, 9. So you are probably well aware that the Arctic in Alaska is warming more quickly than the rest of the world. And because of this, we decided to focus a chapter on indicators relevant to Alaska. And we do have a few in the indicator suite that we could feature. So we'll walk through US and global temperature, Arctic sea ice, a closer look on the Black Guillemots of Cooper Island, permafrost, ice breakup in 3 Alaskan rivers, and leaf and bloom dates in Alaska, which is actually one of our new metrics. All right, so next slide on 10. So the temperature is a fundamental measurement for describing the climate, of course, and as concentrations of greenhouse gases in the atmosphere are increasing, average temps in the Earth's surface are also increasing and expected to continue rising. So this is our US and global temperature indicator. We have 3 metrics that show changes. These are data collected from weather stations. The indicator shows annual differences compared with an average temperature from 1901 to 2000. And not shown here, but for context, the global average surface temperature and temps in the lower 48 have risen at an average rate of 0.17 degrees per decade since 1901. And since the late 1970s, the US has warmed more quickly than the planet as a whole. And shown here, you can see the map featuring the US and also Alaska, and you can see that Alaska is clearly an area of the country that is experiencing quite pronounced warming. Next slide, 11. So the chapter also features Arctic sea ice, so which that's directly affected by warming air, water temperatures, and really important for communities and wildlife. This figure uses National Snow and Ice Center data and shows Arctic sea ice extent from 1979 when routine monitoring by satellite started. While data are collected throughout the entire year, this figure focuses on the months when sea ice is typically at its minimum or maximum extent. So September is when sea ice is at its minimum after melting during spring and summer. And that is shown in the orange line in the figure. And this past September was the 5th smallest on record. The online indicator includes metrics on sea ice age and also length of melt season using data processed by University of Colorado and NASA. And now I will pass it on to my colleague, Sargon.
Thanks, Lisa. I'll actually just point out about Arctic sea ice. It just so happens we hit the September 2024 minimum just a couple weeks ago, and that one actually is at 1.65 million square miles sea ice extent. So that one bumped 23, I guess, down unfortunately to sixth spot. It's the third. So last year was the third sort of smallest extent of Arctic sea ice since it began. Record keeping began in 1979. So yes, certainly nothing that contradicts the trend here. So Lisa took through the temperature and then for Alaska in particular, and then walked us through Arctic sea ice here. And you can see sort of this pattern emerge of looking at the stepwise consequences from one to the next. Talk about temperature, how that has repercussions for, especially for frozen environments. Throughout Alaska, different, I should say, frozen phenomena in Alaska. And we're going to turn now to sort of like one case study with the next slide, looking at a specific species of birds that nest on a small island just outside Utqiagvik on the north slope of Alaska, and this has been monitored by one scientist for decades now, and these are birds that depend on fish that tend to congregate at the sea ice sort of uh, interface, like right where the sea ice ends. And so as sea ice extent has not only declined but shifted, those colonies of birds that depend on those fish have had to travel farther to get to where that where their key prey happen to be. So this is just again trying to illustrate how what seemingly seems just a physical metric, that we quantify with either degrees or with square miles, has real repercussions for components of our of local ecosystems. So you can see the decline here in terms of number of breeding pairs from upwards of 200 in the late 80s and 90s down to 24 breeding pairs of this species in just this one little case study. Next slide. We also focus on some of the terrestrial frozen phenomena in Alaska, and as many of you know, permafrost is a really important fixture of the landscape in terms of how it's a permanent feature of the Alaska subsurface. This indicator, which we draw from the University of Alaska Fairbanks, look at boreholes throughout Alaska going back to the 1970s, and how the temperature of that is sampled at 50 feet of depth or greater, um, what that permafrost is reading over time. And what we can see in lockstep with what we saw in the temperature changes, this much greater warming the further, the higher latitudes that we see in Alaska. So again, reinforcing not only the consistency of the changes that we're seeing and the trajectory of those changes, but also discussing some of the repercussions that we have for not only ecosystems, but for infrastructure, for communities that whose community structures are suffering from instability. So we touch on that briefly. So can move on to the next slide. And in addition to some of the land metrics, we also look at this particular indicator focuses on river ice. And so there's some communities in Alaska which have been documenting annual spring thaws of the breakup dates on Alaska rivers, and they've been holding these contests where they'll collect money, and whoever guesses the closest to the right moment, the precise moment that ice breaks up on these rivers in the spring, would be the winner, say. So some of these contests, as you can see, date back to the 19th century, really remarkable, and have maintained annual records. Something that we really prize is that annual record over long periods of time, with comparability over that time. So in 3 locations, we document that, and as you can see, again, we sort of have this same reinforcing pattern of earlier shift here, indicating warmer temperatures, where that ice breakup migrates slowly and slowly earlier in the year, each spring. So that phenological indicator demonstrating again that warming temperatures are affecting multiple dimensions of the Alaska landscape on the order of more than 1 week in over the last century in this case. So next slide. And this is sort of a nice parallel to the one we just talked about. This one looks at leaf and bloom dates. So again, another timing-based indicator, right? Looking at, again, in the spring, how are things shifting to be warmer earlier in the year? In this case, on this graph, what you're looking at are two different lines, two different sort of sets of series. You have the blue series, which is a leaf date for lilacs, and then green are bloom dates for lilacs, and you have the thicker smooth line, which is averaged over I believe 9 years, 9-year moving average, and then you have the annual values in sort of the spiky version. And as the line descends, it shows just how from the baseline how much earlier lilacs are blooming or leafing, as the case may be. And we don't have the national trend here to compare. This is in addition. This is studied just in Alaska, but the changes are much more pronounced in Alaska. We're seeing we actually had to change the y-axis on this to accommodate just how great the change was on this, for Alaska as it is compared to the rest of the United States. So again, startling in its not only its scale in terms of how dramatic that shift has been. We've talked about on the order of 2 weeks here over the course of 70 some odd years. So really quite a startling change. We can move to the next slide. This is one of our newest indicators. In one part of our report, we do talk about heat in particular across the whole United States, and we're all, I think, familiar with the concept of a heat wave in the summertime. What really temperatures spike and turn up the AC, and in many cases, if of course, if you have AC, in some cases, really significant cost to human health, and really affects large populations of people who are unable to cope with really high temperatures. But those same effects and those same events also happen in the ocean and as marine heat waves, and of course life there also has to endure the different circumstances. So you might have heard last summer, just in July of 2023, there were headlines about the bathtub level temperatures in the Caribbean Sea off the coast of Florida. I think it went up to 101 degrees Fahrenheit, something really eye-popping numbers in terms of just how hot it got down there. And so it just so happened that we were developing this indicator, which I think does a good job of capturing some of those key messages. This looks at degree days, so it looks at both the intensity of a marine heat wave, so and the duration. And in this case, a marine heat wave are those events that are above the 90% threshold of unusual temperatures for a given grid cell, and at any time of year. So a heat wave is not necessarily based on a certain temperature threshold, but just how unusual it is for that time of year. Given, of course, that fish migrate, and the fish that might be there in January might not be used to those temperatures. So this takes into consideration some of the impacts for a specific time as being particularly threatening to the ecosystems there. And what we're seeing is that, if dating back to data going back to the early 1980s, that we see a rise in intensity of these marine heat waves, pretty much in all U.S. waters, but some stand out. And in this case, we have a really dark red patch off the coast of New England, but also southwest Alaska there. We can see another hot spot for these marine heat waves, showing that in those particular areas, species really are seeing these intense conditions more often. Next slide. Oh, that's it. All right. Well, here we are. We've reached the end of our presentation. Look at that, 30 minutes on the button. So we're here to answer your questions. I just want to reiterate again, we're happy to take questions about the indicators that we presented here, or if you've been, snooping around our website right now, just taking a peek at all the other 57 indicators that we have. Happy to answer questions about those. But we'd also love to discuss with you. I mean, when you see some of these concepts that we've just briefly touched on, what are some ways that you've found you can communicate these to your stakeholders, people that you engage with on a regular basis? We'd also love to know if you say, oh, I know a great data set, or know a great topic that you guys, might want to consider. We would love that. We are constantly looking out for new opportunities to feature the rich amount of climate data that's out there. So yeah, hope to open up the floor and talk with everyone here.
Thank you so much, Sargon and Lisa. If everyone can give a virtual round of applause for a wonderful presentation. We do have now time for Q&A, and you have a couple of different ways that you can ask a question or make a comment. You can put it in the chat for everyone to see, and I will read it out. And you can put it in the chat just for me to see, and I will read it out without your name attached. And then your third option is to use the raise hand function that's under your reactions button on the Zoom toolbar. And that'll let me see that you would like to speak, and I will invite you to come off of mute. So you can use any of these methods. One is not better than the other. And perhaps as we're waiting for questions to be entered in the chat or hands to go up, I will ask. I know, Lisa, you mentioned the number of people that go to the website, which is very impressive. I think you said 900,000 over the year, which is amazing. Do you have any information about how the data are being used? Like, are communities using it for response efforts? Are scientists using it? Like, who's using it and how?
Excellent question. One of our key users is students and educators, actually. We do know that indicators are included as kind of a driver for adaptation, mitigation, action, and state and community level work. The set that we have is, mostly nationally focused, and we don't include as much downscaled data that would be at a spatial level that is as actionable as some of the climate data that's out there. And that's kind of by design from the original intent of the project, to show these kind of bigger, broader changes happening over a larger area. But it's something that we've been looking into and trying to do better. For example, we have a heavy precipitation indicator that we're looking at downscaling currently, because we know that the story is really different in different parts of the country. We're constantly on the lookout for how folks are using our information. So if you have used the indicators, would be interested to know.
Yeah, I'll just add that we don't always get people don't always tell us when when they end up using our data, and it'll just be happenstance. Oh, I read a state action plan on a state climate action plan. Look here, there's our figure right there. And so it's mostly opportunistic. Either we happen upon it ourselves just in our reading, or someone will reach out. Someone will mention it in passing. In fact, I just in my personal life, I just happened to cross paths with someone who was a science teacher, and mentioned that oh yeah, I work for EPA and I worked on this report, and she's like, I use that in my classroom. And so that's sort of like the level of information that we're able to get on this, because we are a public resource. We obviously we don't have any constraints in terms of using our content, so it gets out there into the wild, and we don't always get reports back. So yes, please, if anyone has been using our data, please let us know. We'd love to know about it.
Thanks, Sargon. Thanks, Lisa. There's a anonymous question to me, or suggestion almost, which is someone is wondering if it would be worthy to track long-running sled dog races being rescheduled or moved to new locations due to snow and open water as an additional indicator.
Yeah, that would be really interesting. Those kind of like long-standing traditions, lake ice, like fishing competitions that are canceled. There's kind of a few that we've looked at, but if you know of where to find some of that information, please send it our way.
Great. And then we have a question from Brian Melzian asking, in regards to the marine heat waves in Alaska, do we know how they compare in terms of intensity, duration, spatial extent, with the heat waves in the contiguous US and the rest of the world?
Yeah, I'd have to dig a little deeper. I mean, like, the scale's the same. So we could, if you pop over to the website and take a look at that map, the scale is roughly the same. In terms of how they differ, obviously what's there is a trend over that 41-year period. So in terms of, whether there's like there's in the last few years, it's been particularly more acute. I can't say. I'd have to take a deeper look. And of course, in some ways, it's good that we have really good spatial resolution here, but in some ways, it makes it a little bit harder to tease out some of those trends that you're talking about. So, yeah, we can certainly follow up offline and give you a more comprehensive answer. I realize that wasn't perhaps as detailed as you might like, but it is tough to tell just from this, what essentially is a one trend, and you don't get that interannual sort of granularity from this map.
Thank you. I'm also noting, if I can find my chat, we do have the slides available for download on the event page. I've just dropped the link in the chat because I know there are a few links on the slides. And so if you would like to be able to access those, there's a PDF there that you can download and the link should be clickable. I also dropped the link to the climate indicators webpage earlier in the presentation, but I will drop it again after I read Rami Wood's question, which is whether there has been any collaboration and consideration of data sovereignty or community engagement for building more co-production relationships and work related to these indicators.
Yeah, and it mentions the equitable resilience builder. And so we actually, we've met with some of the folks who developed that tool a few weeks ago, a couple of months ago. Time is flying. But yeah, and the indicator data set takes in kind of off the shelf processed data that's for the most part already publicly available. And so that's definitely have interest in collaborating with data providers and experts and folks on the ground to, especially from Alaska, because we don't have as rich. We have a lot of data sets. A lot of them, you noticed, are kind of more, smaller spatial scale, like the rivers, the guillemots. And so kind of having something that better represents the state would be great. The data sovereignty is something that we have thought about and probably have, in our reliance on publicly available data sets. I haven't encountered kind of challenges as of yet. But it would be interesting to think more about and definitely learn from those folks who are doing the ERB.
Thank you. And I have another question while folks are perhaps thinking of more, which is about the black guillemots. How did you choose that particular species to focus on? Was it, again, the focus, the availability of data, or is it a particularly salient species?
It was the data, because it goes back so far. It's tracked on an annual basis. And a colleague met the researcher at a conference, and it was a really kind of compelling story. It just shines that light on the kind of bigger picture as it's showing a data set that kind of told more of a story that, that could show these impacts. It's not, we don't just care about the guillemots, and those, nest boxes that they originally nested in were left by, it was an installation on the island. And it was just, someone noticed they started using these boxes. And so it was this unique opportunity to track. But yeah, it's not every year that it's not a happy story that is being shown. Yeah.
Are there additional questions or comments from the audience? Again, you are welcome to put it in the chat. You're welcome to send it to me anonymously, or you can ask out loud. Joshua Reddy, I see that your hand is up, and I hope I pronounced your name right.
Close enough. So this is really interesting, and I'm like looking at the website like while we're talking here, and trying to understand a little bit better. So you have all these different indicators, and they're sort of all next to each other. Is there any sort of way in which they're summarized for a given year, like the sort of a overview that incorporates the different factors into sort of some metric or summary or something like that you do over time?
We don't have that. That's a really good question. We have some story maps that feature certain indicators and different themes. And then the kind of closest thing that might get to at least visually getting at that is the map viewer, which looks at, you could look at the different spatial layers. Yeah, but we don't have a product like the, a yearly update. But that would be really interesting.
Yeah, I guess, Joshua, was your question more about like having some sort of rolled up index that says, I don't know, like a climate severity index, like how much worse is it getting on sort of a comparable metric from one year to the next? Or do you mean like an annual, like just here's sort of the top line, what's been happening in climate the last year in terms of the 10 of our indicators? I'm curious
Yeah.
what you
I guess I was thinking either way, because I know that there's different agencies out there sort of put out their either forecasts or assessments, looking back at weather and climate in Alaska, in particular, in different ways. And some of them sort of have those sort of retrospective, some of them are more looking forward, and some of them are just looking at trends. And I was just sort of wondering if there were any sort of ancillary things other than this list of indicators and their trends and patterns. But I think this is really cool. I'm just sort of trying to, I haven't gotten through the whole website, and I was trying to think of like how you, like if you do an annual report sort of thing that would either use either one of those approaches. And I'm not necessarily saying you need to. I was just curious.
Yeah, I no, so yeah, just as Lisa said, we don't do that currently. It is an interesting question. I mean, one of the challenges we face is sort of balancing the quickness of an update, when data are available, versus waiting to like have a bit more of a splash with oh, we updated 15 indicators at once in batches, and which would lend itself to sort of what you're talking about, saying, hey, there's been a bunch of new content here that can tell you the latest about 15 features in our environment. So I mean, if that's something that you're hearing would be a valuable thing for EPA in particular to have, or at least we could put our heads together and think of a way to do that makes sense, leveraging some of our data. So I'd love to hear more if that's something that you would if you think that there's an appetite for it.
Thanks. I think I'm going to look more at the data and think about it.
Sure.
Thanks.
We definitely have lots of dreams about different things we can do, and infographics and different ways to present the information. So yeah, that would be cool to think about. I think you're muted, Liz.
I'm muted. The classic faux pas. Switching back and forth just between the chat and the hands, there is a question directly to me, wondering if there are Alaska-based social scientists participating on the team that puts this together.
Good question.
Do you want to say?
Yeah, we're a small team of three folks. We work with a number of data contributors, and there are some more social scientists that we've reached out to look at different topics. So within our own agency and our Office of Research and Development, there are a few folks that we've been talking to. So not working directly on the indicators team, but I think our team is 3+, our vast network of data contributors and providers. But yeah, the social sciences and its kind of metrics are something that are definitely a gap right now in the indicators. And we've had a lot of challenges, even just with some of our kind of health related and societal related metrics because of the length of the data set, changes in reporting, things like that. So yeah, interested if there's any metrics that are more kind of in the social science realm that folks think would be interesting to see.
Great. Martin, would you like to come off mute?
Sure. Yeah. Thanks for the great presentation, Lisa and Sargon. This is an incredibly useful compilation of useful information and very helpful. I just one note I have. We have now a lot of different climate reports, and we get regularly questions. So, what is the climate change right now? And I would wish if we would agree on some common statistics. If you draw annual temperatures on a chart and then create a trend line, it's not really the climate related temperature change. So you get a lot of different numbers, and it would be nice if everybody could work together a little bit there. It's not just temperature, it's all different variables. That's one comment, but otherwise, thank you very much. That's very helpful. Great work.
Thanks, Martin. Yeah, and I totally hear you. There's such a challenge in being both effective communicators and in preserving the scientific accuracy of what we talk about, right? And so I think that's a little bit of what you're getting at, is like, how do we talk about these physical changes in a way that really gets at the heart of what's actually happening in a trend, but also make it interpretable. And I'm just going to use one example. You mentioned temperature, but I'll actually pick on heat waves, right? So like, there's so many different ways that we can, we think, oh yeah, we know what a heat wave is, but do we really? Is it based on a on land now, not marine heat waves, right? Are we talking about a threshold over 95 degrees Fahrenheit? Are we talking about an event that happens one day? Are we looking at the maximum temperature that day? Are we talking about the average temperature that day? Are we talking about a 2-day event, 3-day event, 4-day event? Are we looking at the minimum temperature, right? Like, there are any number of ways that we can slice it. Are we looking at that 95 degree threshold, or are we looking at, like we did in the marine heat wave one, are we looking at something that's unusual for that time of year? And so, and this is why I caution, at least in my personal life, and I sort of caution everyone, like, don't read the headlines, right? Because the headlines are so notoriously bad at just saying, oh, heat waves are this or heat waves are that. But the definitions, like, you can make 25 different definitions of what a heat wave is. Now, I'm not saying that they won't be at least similar in trend if you go back, many decades. I would imagine in lots of different ways that you slice it, that there would be a commonality to many of those. But what's that line, that there lies damn lies in statistics, right? Like, isn't that, I think that's a famous quote, right? Like, so that's why we sort of have to really make sure that when we're presenting these data, that we do it in a way that doesn't just do short shrift to the technical specifics, right? That we're presenting the data accurately, we're using the right terminology, and then most importantly, and this is one of our core tenets, is ultimately transparency. We have our data available for download. We have our technical documentation that goes into really lengthy detail about all these things, about how the metrics were calculated, where they come from, how to reproduce them. So sorry, that was a really lengthy response, just to say, yeah, I totally hear you and agree with you. And it's a challenge I think we all have in climate communication, is maintaining that balance.
Yeah, exactly. Thanks a lot for the explanation. Yeah.
Thank you, Martin. I'll put out one more call for questions or comments.
And I'll add also, if people think of questions later, feel free to contact us. We have the email on the last slide, and we can also share my email and Sargon's email. So whatever way you want to get in touch with us after the fact is fine too.
Great. Well, I'm not seeing additional questions. Lisa, Sargon, are there any final thoughts you would like to leave the group with?
Yeah, just we thank you so much for having us to present here, and yeah, we'll take in this feedback and hope that you visit our website moving forward.
Great.
Yeah. Thanks everyone. Thank you. Thanks Liz for having us and hosting us. And yeah, encourage anyone to reach out. I'd love to make more connections.
Thank you both for presenting. This has been recorded. I will post it on the IARPC Collaborations website probably by the end of today, if not by the end of tomorrow. So you'll be able to find it soon. The slides are also there. I will also edit that page with the links that have been shared in the chat, including the emails, so that you can contact Sargon and Lisa if you have additional input. Please, if you haven't already, join IARPC Collaborations so you can learn about future webinars. And thank you everyone for joining us. And thank you again, Lisa and Sargon. Have a great day, everyone.